perpendicular here, and then we have to find out this thing. Okay, so let's understand how this geometry is there. So suppose I have a circle like this. And this, any 2 points, let's say A and B. A, let's say B is over here, and A corresponds to the complex number A, and B corresponds to the complex number B. And how do I know that the A and B are complex number? You see
because
the line
inside the bar they've given us.
Yes, it means they're given A means, of course, it cannot be the like a one coordinate point. It can't be possible. So A must be a complex number. Then only it will represent a point. Is it clear? Now here, if we join A and B, I will have a line, and on that line, I'm dropping a perpendicular from, let's say, the point P. I don't know where the point P is. Let's say Z, and I drop the perpendicular from here. Okay. And that perpendicular meets this line Q, line AB at Q, whose complex number coordinate is W. So I have to just relate these things and take the ratio. Of course, you see this one thing, that this is ZW is a complex number. A is a complex number, B is complex number, Z is complex number, A, B, Z bar, all are complex number. So complex number by complex number, and this is the numerical integer answer, it is only possible that some ratio is happening there.
Yes, sir.
Correct? So in one way to do is to write the equation of the line AB joining 2 points in the complex number system, and then again we find out this Q by solving. But also one thing you notice, that suppose I'm taking any general point on this line. If I take any general point on this line, what we write for that?
B minus.
Okay, let me just rephrase it. Suppose I'm taking any general point. But this general point x comma y, you can see. Line also x comma y is there. Okay, so just forget. I have any general point, let's say here, or let's say z is a fixed point, doesn't matter. Let's say I have a this point is u actually. Now how do we write this u? Just suppose I'm taking this vector in this direction. Okay, in this direction. So what we understand, that the argument of the u minus a divided by then again b minus a is 0.
Yes.
Is it correct?
Yes, sir.
Same direction vector. No? Okay, so what do you write there? Argument of, sorry, not argument.
U minus a is equal.
It means I can write this u minus a by b minus a is a real number, correct?
Yes, sir.
So then what we write? It means it's a imaginary part is 0. So u minus by b minus a must be equal to u bar minus a bar b bar minus a bar, correct?
Yes, sir.
And then what we notice, that this, you notice one thing, this b and a are on the complex number, means a, sorry, on the circle. A and b are on circle which is unit circle. So I can safely say that it will satisfy the equation of the circle. Let's say x squared plus y squared is equal to 1. It means x squared is equal to 1. By the way, this z is not that z. So you am taking any variable. So I can say that the mod A square is also 1 and mod B square is also 1.
Yes, sir.
It means A bar is equal to 1 and B bar is also 1. So in this way, what we can do that I can substitute the U bar and B bar with 1 by A and 1 by B. So U minus A minus A. And here U bar 1 by A, 1 by B minus 1 by A. If we give you U minus A, B minus A, and here what we get? A times U bar minus 1 divided by what? A times, and here we have A minus B, correct?
Yes, sir.
Notice now this A bar. By the way, this will give you on the top also what we get? AB.
Yes, sir.
This again AB. And what will happen here?
A, B and A minus B and B minus A also we can cancel, sir. We can write it as
and minus of A B U bar.
A U dash minus B.
U dash. A B U dash minus
B.
So from there, what are you getting?
U minus A is equal to B minus A B U dash.
U minus A is equal to B minus
A
A B U
dash.
conjugate, correct?
Yes, sir.
Therefore, U is equal to A plus B minus ABU.
AB.
ABU conjugate, correct?
Yes, sir.
This is one relation we got. But notice on this line, actually I have taken U. But don't you think that this also satisfies the W because W lies on the same line?
Yes, sir.
So I can substitute there W. So W is equal to A plus B minus AB W bar. Correct?
Yes, sir.
So this I'll keep it in hand. And then we go for the other relation to construct. How do we construct the other relation? See. This one we are going from here to here. It means that you can mute your mic actually. Okay. So you can go from here to here, and then what we observe that is a 90-degree rotation. So what we can observe that the angle between these two vectors, this vector and this vector, is 90 degree. So what we can write is the argument, since we are going on that vector, so B minus A divided by, and going from this, so W minus Z must be pi by 2. You understood what I said? Here, what is happening from here to here going? So this, and this is an anti-clockwise direction rotation. So this vector is given by Z minus W, and this vector is given by B minus A, and we are rotating from here to here. So you know the rotation rule of the complex numbers. So that will give you the argument of this is pi by 2. Correct. So from there, what we get that this is pi by 2 means this complex number is an imaginary complex number. Correct. So real part is 0. So what is real part? B minus A by W minus Z plus the conjugate of it. That will give you the twice of real part. That should be 0. So what we can write is equal to the conjugate of it. It means minus of B conjugate minus A conjugate divided by W conjugate minus Z conjugate. Again, we apply the same technique. Let me take this question down. So again, we apply the same technique here. And again, we write is B minus W, B minus A, W minus Z. And here I'm writing again 1 by B minus 1 by A divided by W bar minus Z bar. So you notice that this is going to be B minus A, W minus Z. And this is minus of A minus B by 1 by AB here. And this is W bar minus directly with a minus sign. So what we have to evaluate here is we have to evaluate 4W divided by A plus B plus Z minus ABZ bar. Correct? That I have to evaluate. So can we just relate these two things? Can we relate these two things? You see that here, what I'm getting. You notice that this thing, the Z minus ABZ bar, these two collectively I can write as W minus ABW bar, correct?
Yes, sir.
So Z minus ABZ bar I'm writing as W minus ABW bar. Correct. And you notice one thing here again, that W is equal to W minus A. Okay. Yes. So I can write now here, you see that this A plus B minus this thing here, A plus B minus ABW bar, directly I can write what? W, correct? So what I got? 4W by 2W is equal to 2. So the answer is 2. Understood?
Yes, sir.